All right, our next conic section is parabolas. You have done parabolas before and they were always just like x squared. X squared makes that parabola shape. That is true. We're also going to talk about what if it's just y squared. So if you look at this one on the right here, you'll notice it's going sideways. We previously have not talked about parabolas going sideways because they aren't technically functions, because they don't pass the vertical line test, but they do exist. And you'll notice some new words here about a focus and a directrix. The vertex is the same. It's, the minimum or maximum. But for a focus, it is a point. Notice it's just a point. Whereas the directrix is an actual line. Neither of them touch the parabola, and here's why. So if I look here at this fancy GeoGebra thing here, I have a normal parabola that we're used to. This one actually has what I say is P is 1. And what that means, so the actual definition of a parabola is that I pick a point on the parabola, and the distance from that point and the focus is the exact same as the distance from that point and the directrix. So if you looked at where I stopped right here, the distance was 9.67. And that happens all the way. That's how the parabola is actually created. We're going to be responsible for finding P in our equations. So just notice that P is whenever it is like how far is the vertex from the focus and how far is the vertex from the directrix, and it's the same. Of course, I can move my vertex, but the definition of the parabola stays the same because the focus and the directrix stay the same. Notice what happens when P becomes negative. That's how I get it to flip upside down. And then we will also be talking about y going side to side. So for the sake of this video, make sure that you have this, and then meet me in the next video for the actual examples.